Once you've created your circuit, it's time to start programming it. Let's start by trying to light up the green LED. The first thing you'll want to do is to close the components drawer there and click on code. When you do that, you're going to be shown a coding window that allows you to program with blocks. Unfortunately, you can't do as much with blocks as you can when you program with real text-based language. So we're going to switch to text, and you're going to be given this warning. Are you sure you want to close the blocks editor? Any blocks you currently have will be lost. The code in the text editor will remain and become editable. We're going to hit continue. The thing you need to remember is you cannot switch between text and blocks once we click the continue button. If you do so, any text that you write will be lost. Now you can see that the text window here is taking up about half the screen. That's going to be a little bit of a problem for us. So what we're going to do is scoot our circuit over just by clicking anywhere on this blank area in the background and then just dragging it. Now what I suggest that we do is create a variable to refer to the green LED. And to keep it simple, I'm just going to call it green LED. So I'm going to hit enter right here, and then I am going to type byte green LED. And I'm capitalizing all the letters in LED because that stands for light emitting diode. Then I'm going to put equals, and I'm going to put the pin that it's attached to. So if I follow this wire down, I see it's attached to pin 6. Now you see a little dash or a tilde in front of the 6. That indicates that it's a pulse width modulation pin. You don't need to put a dash or a tilde in front of it when we create the variable. You still just put a 6. And then semicolon. So now we have a way to refer to pin 6 in a readable way. We know that we're going to be referring to a green LED every time we see it in code. So the next thing we need to do is we need to set the pin mode for that. And since we've already got a pin mode command here, I'm just going to use this one and swap the 13 for, I could put 6 here, but that's a little hard to read down the road. Instead, I'm going to put green LED. Then down here, I have several lines of code. I don't need all of them. I really only need this first line right up here. And so I am going to delete these other lines of code. And instead of 13, I'm going to put, again, green LED. And now if I run the program, I should see my green LED light up. Now, you're going to see a little exclamation mark next to your green LED. That's the program telling you that the LED is drawing too much current and that it would either be harmful to your Arduino or your LED. But like I said, in practice, I don't find this to be the case, and I wouldn't worry about it. Let's stop the simulation and now focus on what we're going to do to light up all of these red LEDs. I want to light them all up. So if I can light them all up, then I know that I'll be able to control them later on when I start writing additional details for this program. Now, there's a lot of different ways I can do this. One way would be to do it in a similar way to the green LED here, but I'd have to be a little bit more specific. I'd have to call this like the center red LED, and then maybe the near left LED, and the middle left, and the far left. So just to show you what that looks like, I'm going to start coding it the same way that we coded the green LED. I suggest that you do not follow along, as this is a very long and tedious way to accomplish our goal, but it is worthwhile for you to see what it's going to look like. And then once I show you the long drawn out way, I'll go ahead and show you a much more efficient way. Now that I have all of the variables created, it's time to set their pin modes. And once I've set all the pin modes, then it's time to go ahead and set or actually write to those pins so that we can set them high and turn them on. You can see here I've got it in the loop. I could put these lines right down here at the bottom of the setup, but just to be consistent with what we've done with the green LED, I'm going to go ahead and put them down here in the loop. Now that I have all of my digital write commands written down, I can go ahead and try to run the code. Let's see if I've made a mistake. And despite all of that typing, it looks like I was successful. You can see every single red LED lighting up here. Um, One thing I want you to note is how many lines of code it took to do this. To control all 7 red LEDs, I had to create 7 variables, set their pin modes, so I had to do that 7 times, and then down here I had to write 7 digital write commands. So that's 7, 14, 21 lines of code just to light up the red LEDs. Okay? Now it's time to show you a more efficient method. I'm going to get rid of all of those, and I'm going to get rid of all of those, and I'm going to get rid of all of these variables. While it's certainly possible to write our program using regular variables, there's a much better way. Regular variables only let you store a single value. If we create an array, we can store multiple values. Think of it like the difference between a regular mailbox and a community mailbox. With a regular mailbox, there's only one place to store mail, but with a community mailbox, there are lots of places to store mail. Like community mailboxes, arrays allow us to store information in lots of places so that we can use the same name. Think of it as using the same address. To access a specific piece of information within the array, you must include its index. That would kind of be like including the apartment number for an apartment building. To create an array, I'm going to type byte, and then I'm going to refer to all of these red LEDs here collectively. I'm going to call all of them scoreboard. They are what tell us who's winning and by how much. And then at the very end, I'm going to put these square brackets. That indicates that I'm creating an array. And then I'm going to put an equal sign. And then I have to use curly braces here. And then I'm going to put in the pins. And I've got to do it in order for all of these LEDs. So the first one is 10. So I'm going to put a 10. And then the next one is 9. And then 8. And then 7. And then we have to skip 6 because that's attached to the green LED. And I'm going to go to 5. And then 4. And then 3. And that is all of our red LEDs. So in one line, I've declared a variable that refers to all of our LEDs. Don't forget to put your semicolon. Next, just to help you understand how arrays work, we're going to include a line at the very beginning of our setup called serial.begin. And I'm going to put 9600 here. That's the default baud rate. That's the default rate at which serial communication happens on an Arduino, or most Arduinos. And then I'm going to do a serial print line right here at the bottom of the setup. And we're going to see something that you're probably going to be surprised about. I'm going to say serial.print ln, that means print line. Every time it prints, it'll print on a new line. And then I'm going to put scoreboard. And then in brackets, I'm going to put 1. Now, you're probably thinking that this is going to print the first item in our scoreboard. I'm going to go ahead and run it, and I'm going to pop open our serial monitor before I do that. So we should see the output from this serial print statement show up right down here. And let's see, it shows a 9. Well, that's the second item in our array. That's a little bit confusing to me. Why would that be the case? Well, it's because arrays are zero indexed. The first item in the array, in any array, is considered the 0th item. So it's got an index of 0, and the second item actually has an index of 1, and then 2, and 3, and so on. So if I wanted to see the first item in the array, or the item with an index of 0, I'd have to put a 0 right here. To do that, I first have to stop the simulation, and then click right here, replace it with a 0, and then I'll run it again. And you can see now it shows a 10, which is indeed the first item in our array. Now that we understand that arrays are zero indexed, we can move on to trying to light up all the items within our scoreboard here, all the LEDs in our scoreboard. So to do that, I think we can close our serial monitor now. I'm going to go ahead and delete this line of code because it might confuse us a little later when I'm trying to explain other parts of how this program works. And I am going to move on to creating a for loop. So this can be a little bit tricky. The way to create a for loop is to first type for, and then you have to come up with a starting value. I'm going to put byte here because we don't need a variable that's going to take up a lot of space in our memory. And a byte is one of the smallest, it is the smallest variable we can make. I'm going to call it x, and I'm going to start it out at 0. Why am I starting it at 0? Because arrays are zero indexed. Then I'm going to put semicolon, and then I'm going to say x is less than, and I'm going to put 7 because how many items do we have in our array? We've got 1, 2, 3, 4, 5, 6, 7. So because there are 7 items in our array, I'm putting a 7 right here, putting another semicolon, and then I can write this part here in many different ways. I could write x equals x plus 1, or I could write x plus equals 1, or I could just write x plus plus. I'm going to write x plus plus because that's the most concise way to do this, and it's something you're going to need to get familiar with because you're going to see it a lot. And then I'm going to hit enter. The line that directly follows this for loop statement is something that's going to be repeated 7 times because I'm starting at 0 and I'm doing it until right before it's less than 7. The first time we go through the loop, the value of x will be 0. The second time, the value of x will be 1. The third time, the value of x will be 2, and it will keep doing that until we get to the condition at which x is no longer less than 7. In fact, I can show this to you by doing serial.println and just printing an x. I'll open the serial monitor again, and I'm going to clear it so we don't confuse this data with the data we have right here. I'm going to start the simulation, and you can see that it printed a 0, a 1, a 2, a 3, a 4, a 5, a 6. It didn't print a 7 though, because when x gets to 7, 7 is not less than 7, so the condition actually resolves to false and we jump out of the for loop. But I don't really want to write a serial print line here. What I want to do is I want to set some pin modes. I need to be able to control my LEDs, and in order to do that, I need to set them to output so that I can send information to them, like turning them on and off. So I'm going to set pin mode, and then I'm going to type scoreboard, and I'm going to put in brackets the X. And what this does is it actually grabs the correct pin for each index. So for the index of 0, it's going to grab pin 10. And then it's going to set it to output. So in 2 lines of code, I have accomplished what I previously accomplished in 7 lines of code. Down here, I'm going to do something very similar to what I have right here, but again, I'm going to use this for loop. In fact, I can just copy this right here and paste it right here. Now I'm going to write digital write scoreboard X high. Let's see if I've done everything correctly. You can see all of our red LEDs have lit up just like before, except instead of using 21 lines of code, I was able to accomplish this with just 1 here, 2 here, and 2 here. Only 5 lines of code are needed to light up all 7 red LEDs. So using an array is a much more efficient system, and if we were to continue doing the previous method of programming each LED individually, you would find that it's even more painful and agonizing when we get further into this program. So this technique will save us a lot of pain and agony. Make sure that you program your LEDs this way.